Let's look at 8.3, example 5, and we'll do some monitoring progress questions with this problem as well. This is modeling with mathematics. So it says a group of friends is launching water balloons. The function f of t equals negative 16t squared plus 80t plus 5 represents the height in feet of the first water balloon t seconds after it is launched. The height of the second water balloon t seconds after it is launched is shown by the graph over here. Which water balloon went higher? First, let's understand the problem. You're given a function that represents the height of the first water balloon, that's the equation, and the height of the second water balloon is represented graphically, and that's the graph. You need to find and compare the maximum heights of the water balloon. We're going to make a plan. This plan is one way that we can do it. To compare the maximum heights represents both functions graphically. Use the graphing calculator to graph f of t equals negative 16t squared plus 80t plus 5 in the appropriate viewing window. And that means that we have to change the window so we can see the entire parabola. Then we can visually compare their heights. So I'm going to show you how you can use your graphing calculator to do this. Let's all get out our graphing calculators. And we're going to go to y equals. Let's type in the equation that they gave us here for the first balloon. We want negative 16t squared, and I'm just typing in x. I don't need to type in t. X is the same thing, just as long as it's an independent variable. Plus 80t, or x, plus 5. Now from here, if I just hit graph, I'm not going to be able to see the whole parabola in this window because it's going outside of my window. So what I'm going to do is I'm going to kind of make my window look like the window for the second balloon, and then I can compare the two and they have the same window. So what I need to do is I'm going to go into window and I'm going to make this happen. So first let's do our x. For my x's, we're going from 0 to 7. Now I'm going to do the same exact thing here. I'm going to go from 0 to 7. And this next thing is the x scale. That means that we go by ones, and we do on this graph, the x's go by ones. Now let's go for our y's. The y's are going from 0 to 150. So let's change that. This is 0 to 150. And now we're going to change the scale. Look at what the graph goes by on here. This is 25, 50, 75, 100. So it goes by 25s. Let's make our y scale 25. Now we can hit graph. And now we can compare these two. And you can see in the book that the graph in the book matches the graph that I just made on my calculator. And now we can compare the two graphs. On this graph here for the first balloon, remember this is 25, 50, 75, 100, and our maximum is just above 100 right here. If I'm looking at the second graph, look at where the maximum is on here. It's right above 125. So because this is definitely going higher, that means that our second balloon is going to reach a greater maximum value. We can also use the maximum feature in our calculator to find out the exact maximum of this point, and I'm going to show you how to do that. So go back to your calculator, and now we're going to hit second, calc. So the trace key, right above the trace key, it says calc. And then if you scroll down, we're going to choose the maximum, so number 4. It says left bound. Look at how your cursor pops up on your screen. You want to move your cursor to the left of the maximum. As long as it's anywhere to the left of this maximum point, that's fine. You're going to hit enter. Now it says right bound. I'm going to move the cursor to the right by pushing the right arrow. Move it to the right of the maximum. Anywhere to the right is fine, and then hit enter. Guess it wants you to try to get right on the maximum as close as you can. And once you're there, then you can hit enter. And it comes up, it tells us the maximum is 2.5 and 105. So we know that the maximum value is just over 100, which is what we said before, is up here at 105. So that's one way to do it in our calculator. We can do it another way without using our graphing calculator by doing it on paper. So I have the equation here written down. This is for the first balloon. If I wanted to find the maximum of this balloon, I would need to find the y of the vertex. So first let's find the x of the vertex, opposite of b over 2a. In our equation, our a is negative 16 and our b is 80. Let's plug it in. We're going to have the opposite of 80 over 2 times negative 16. To simplify, negative 80 over negative 32. And then we can divide these two numbers. Negative 80 divided by negative 32 equals 2.5. Now that's the x of the vertex. Let's find the y of the vertex. So I'm going to take this 2.5 and I'm going to plug it in for the t's. So we're going to have negative 16 times 2.5 squared plus 80 times 2.5 and then plus 5. Let's plug this whole thing into our calculator all at one time because our calculator is going to be able to handle it and it's going to give us the correct answer. Negative 16 times 2.5 squared plus 80 times 2.5 plus 5. And look at that, we get 105, and that's what it said on our calculator. So that means that this maximum height is going to be 105 feet. That's how high our first balloon is going to go. So now again, we can compare that to our second balloon, which was, we said 125, or about maybe 130, and our second balloon will definitely go higher. Okay, let's keep going and let's answer more questions here. We're going to go down to the monitoring progress questions. It says, which balloon is in the air longer? Explain your reasoning. So to figure out which balloon is in the air longer, I want to find out when does the balloon hit the ground. So I want to find this point on the first balloon and this point on the second balloon. So I can estimate the second balloon pretty easily. It's somewhere between 5 and 6, maybe a little bit more than 5.5. Maybe we'll estimate this to be somewhere around, I don't know, maybe 5.75, we'll say. So we're going to do monitoring progress number 10 down here. The second balloon is in the air. We just said about 5.75 or maybe 5.7 seconds. I'm just kind of estimating how long this balloon is in the air by seeing where it hits the ground. Now on this first balloon, it's hard to see where it's going to hit the ground on here. So I'm going to go back to my graphing calculator and I'm going to show you how to do this. So go back to graph and let's look at the graph on the screen that we have. So we have, this is 1, 2, 3, 4, this would be 5, and it's crossing right before 5. So this is just a little bit less than 5 seconds. So our first balloon is a little bit less than 5 seconds. So maybe like 4.9 seconds. And again, these are just approximations. So we can even put the approximately equal to symbols in front of here. So which balloon is in the air longer? That means that the second balloon is in the air longer. Second balloon is in the air longer. Now let's say I wanted to find out exactly when does this first balloon hit the ground. Instead of estimating it from this graph, let's find this exact number here. Remember this number where it crosses the x-axis, remember this is called the 0. So to find the 0, we're going to do, again, second, calc, and then 0 is our second option, hit number 2. Now we're going to do that left bound, right bound thing again. So I'm going to go over to that 0 point where it hits the ground, which is right about here, and I want my cursor just to the left of it. So this is a bit to the left, and I'm going to hit enter. Now it says right bound. I'm going to move the cursor to the right until I can't see it anymore. And you can kind of follow along with your y's that now my y's are negative. So that means that it's to the right. I'm going to hit enter. And then I want to get right on it as close as I can. So I want it to be somewhere around 0. I want it to be on the ground. So this, I would say this number is a little closer to 0. So I'm going to use that as my estimate. And there we have it. It's 5.06 seconds is exactly when it's going to hit the ground. So we can even update this and make it 5.06 seconds. Either way, the second balloon is still in the air longer. Okay, let's answer monitoring progress number 11. It says, which balloon reaches its maximum height faster? So now it's talking about the x, the time that it takes for the balloon to reach the maximum height. The first balloon, I already found out how long does it take for the balloon to reach that maximum height because I found the x of the vertex in my first part of the example up here on the top. When I did x equals opposite of b over 2a, I plugged in my numbers, I found 2.5. That's when the balloon would reach the maximum height of 105 feet. So the first balloon is going to take 2.5 seconds to reach its maximum height. Now let's do the second balloon. I'm going to look at the graph for the second balloon and I'm going to find out where does it reach the maximum height. So I'm just looking at the picture here and it's looking like the maximum is right about here on the graph, and I'm just going to estimate where that is. So it's right here before the 3 seconds, a little bit more than 2.5, maybe like 2.75 seconds. And again, I'm just estimating for that so I can do approximately equal to. So which balloon reaches its maximum height faster? The first balloon, because it happens in less time. The first balloon reaches the maximum faster.